I'm here. I'm Minmo. I made it. I forgot it was Minmo for a second. We're Minmo. And we are continuing with the next chapter. So, let's go. Alright. I'm just gonna go right into it. I don't know how to like warm up to these, or I don't know. Maybe we should do, ooh, that might be fun, just to like get in the groove of it. Let's do the typing test. What was it? Let me go back over here. I don't really know. Do just a little typing warm up. Oh, there it is. I wonder, because this is C#. Can I switch it to plus? No. Oh, wait, stop. Programming. English? Sorry, I'll go back over here. Over here. Custom? What's happening? I thought there was a way to listen. Start practice. Typing test. I really remembered like setting it for C#. Yeah. C++. Typing. Okay, I don't know why that took so long. How do I know? Oh, CPP. Okay. Oh, hey, Airhammer, how's it going? We're just gonna do a quick little typing test to like get into it. Oh my gosh, my earbuds are not connecting well. Alright, I'm just gonna go into it. Void. Engine. Explorer. Oh. Oh no. Engines. Ah. Squiggly bracket. Is that an M? I guess it's an M. I'm like, doesn't really look like an M. It does, but I think it's just the font. It's just odd. Ah. Rusty. Ah. Oh, I like that it's the Okay, I like that. Like if I had my fingers where the home row keys are, I noticed that C++ has a lot of the double colon, but it kind of felt nice like holding down shift and doing it because I don't have to move my pinky at all. It's just like right there. I'm like, oh. So I thought that seemed like it'd be something that'd get annoying, but actually I think I'd like that. I think I'm taking my earbuds out. If the music isn't skipping for you guys, then I don't mind it, but it's bothering me. I don't know. I got a new Bluetooth adapter, and it was improved for a bit, but it's not helping again. I don't know what's causing the like interference, or seems to be worse when I stream, but it does happen off stream as well, like just listening to Spotify and stuff. Maybe I gotta give up on the Bluetooth. I don't know. Squiggly. This is gonna be definitely a more low-key stream and maybe a quicker one, but I did want to just really get into the groove of going live and working on this. Squiggly bracket, we did it. Yeah. Crazy bad. Squiggly brackets got us. Of course, they got us. Okay. Now we can read. Let's get to reading. That was a good warm-up. We should do that each time. Okay. Statements and the structure of a program. Chapter introduction. Welcome to the first primary chapter of these C++ tutorials. In this chapter, we'll take a first look at a number of topics that are essential to every C++ program. Because there are quite a few topics to cover, we'll cover most at a fairly shallow level, just enough to get by. The goal of this chapter is to help you understand how basic C++ programs are constructed. By the end of the chapter, you'll be able to write your own simple programs. Excuse me. In future chapters, we'll revisit the majority of these topics and explore them in more detail. We'll also introduce new concepts that build on top of these. In order to keep the lesson lengths manageable, topics may be split over several subsequent lessons. If you feel like some important concept isn't covered in a lesson, it's possible that it's covered in the next lesson. Okay. Statements. A computer program is a sequence of instructions that tells the computer what to do. A statement is a type of instruction that causes the program to perform some action. Statements are by far the most common type of instruction in a C++ program. This is because they are the smallest independent unit of computation in the C++ language. I just realized I want to favorite specifically the C++ page. Repeat lesson. on. Okay. All right. In that regard, they act much like sentences do in natural language. We want to convey an idea to another person, we typically write or speak in sentences, not in random words or syllables. In C++, when we want to have our program do something, we typically write in statements. Most, but not all, statements in C++ end in a semicolon. If you see a line that ends in a semicolon, it's probably a statement. In a high-level language such as C++, a single statement may compile into many machine language instructions. Advanced readers. There are many different kinds of statements in C++. Declaration statements, jump statements, expression statements, compound statements, selection statements, conditionals, iteration statements, loops, try blocks. By the time you're through with this tutorial series, you'll understand what all these are. Okay, great. Functions and the main function. Okay. In C++, statements are typically grouped into units called functions. A function is a collection of statements that get executed sequentially, in order from top to bottom. As you learn to write your own programs, you'll be able to create your own functions and mix and match statements in any way you please. We'll show how in a future lesson. Rule: every C++ program must have a specific function named main, all lowercase letters, when the program is run. The statements inside of main are executed in sequential order. Okay. Programs typically terminate, finish running, after the last statement inside function main has been executed. Though programs may abort early if some circumstances or do some cleanup afterwards. Functions are typically written to do a specific job or perform some useful action. For example, a function named max might contain statements that figures out which of two numbers is larger. A function named calculate grade might calculate a student's grade from a set of test scores. A function named print employee might print an employee's information to the console. We'll talk a lot more about functions soon, as they are the most commonly used organizing tool in a program. Jeez. Oh yeah, we need to learn those functions. Nomenclature. When discussing functions, it's fairly common shorthand to append a pair of parentheses to the end of the function's name. For example, if you see the term main or do something, this is shorthand for functions named main or do something, respectively. This helps differentiate functions from other things with names such as variables, without having to write the word function each time. Okay. In programming, the name of a function or type or object, type, template, etc. is called its identifier. Okay. Alright, dissecting Hello World, which we have right here. Okay, perfect. Now you have a brief understanding of what statements are and functions are, let's return to our Hello World program and take a high-level look at what each line does in more detail. Hey, calm down. Line 1 is a special type of line called a preprocessor directive. This preprocessor directive indicates that we would like to use the contents of the IOStream library, okay? Which is part of the C++ standard library that allows us to read and write text from and to the console. Jeez. We need this line in order to use the stdcout. I don't know how to say that, like in just speaking. stdcout on line 5. Excluding this line would result in a compile error on line 5, as the compiler wouldn't otherwise know what std count is. Is this the eagle song? There it is. And the wolf. I always forget the wolf's right after. Okay, I see what they're saying. std count is a function, or I don't know, a variable. I don't know. C out and C in. It's a part of the IO stream, so we need to call it to use it. Yeah. Line 2 is blank and is ignored by the compiler. This line exists only to help make the program more readable to humans by separating the include, preprocessor directive, and the subsequent parts of the program. Line 3 tells the compiler that we're going to define a function whose name identifier is main. As you learned above, every C++ program must have a main function or it will fail to link. I want to know what int is. Lines 4 and 7 tell the compiler which lines are part of the main function. Everything between the opening curly brace on line 4 and the closing curly brace on line 7 is considered part of the main function. This is called the function body. Line 5 is the first statement within function main. And is the first statement that will execute when we run our program. std count, which stands for character output. Oh my gosh, character output. Okay. Oh. And the greater than operator? Is that greater than? Or less, I don't know. How do I say this out loud? That operator allows us to display information on the console. In this case, we're displaying the text "Hello World." This statement creates the visible output for the program. Interesting. Line 6 is a return statement. When an executable program finishes running, the program sends a value back to the operating system in order to indicate whether it ran successfully or not. This particular return statement returns the value 0 to the operating system, which means everything went okay. This is the last statement in the program that executes. Okay. All of the programs we write will follow this general template or a variation on it. Okay. I kind of like that last one, the return. I don't remember that when I was doing Java. I know that there were like checks, but like to have that like right at the very end to be like, it's good. Okay. Author's note. If parts or all of the above explanation are confusing, that's to be expected at this point. This is just to provide a quick overview. Subsequent lessons will dig into all of the above topics with plenty of additional explanation and examples. Okay. You can compile and run this program yourself, and you'll see that it outputs the following to the console. Yes, it does. If you run into issues compiling or executing a program, yep. Okay. Syntax and syntax errors. Okay. In English, sentences are constructed according to specific grammatical rules that you probably learned in English class in school. For example, normal sentences end in a period. The rules that govern how sentences are constructed in a language is called syntax. If you forget the period and run two sentences together, this is a violation of the English language syntax. C++ has a syntax too. Rules about how your programs must be constructed in order to be considered valid. When you compile your program, the compiler is responsible for making sure your program follows the basic syntax of the C++ language. If you violate a rule, the compiler will complain when you try to compile your program and issue you a syntax error. Let's see what happens if we omit the semicolon on line 5 of the Hello World program like this. Oh. Feel free to compile this ill-formed program yourself. Visual Studio produces the following error. It was... I don't need to look it up. It was F7 to compile. Hey ho. Expected a semicolon. Syntax error. Missing semicolon for return. That's interesting. That was... saw it as before. What was that? Alright, go. All good. One succeeded. Compiler is telling you that it encountered a syntax error in line 6. It was expecting a semicolon before the return statement. Oh, that's exactly what it said. But it didn't find one. Although the compiler will tell you which of the line code it was compiling when it encountered the syntax error, the thing that needs to be fixed may actually be on a previous line. In this case, we conventionally place the semicolon at the end of line 5. What? Okay. Syntax errors are common when writing a program. Fortunately, they're typically straightforward to find and fix, as the compiler will generally point you right at them. Compilation of a program will only complete once all syntax errors are resolved. You can try deleting characters or even whole lines from the Hello World program and see different kinds of errors that get generated. Try restoring the missing semicolon at the end of line 5 and then deleting lines 1, 3, and 4 and see what happens. 1, 3, and 4. 1. 3. And 4? Go. Ah! They're like, whoa, 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 whoa. No shot. Okay. Ooh, quiz time. Following quiz is meant to reinforce your understanding of the material presented above. Question number 1. What is a statement? Statement has a semicolon at the end. It is something that you tell a program to do. Statement is an instruction in a computer program that tells the computer to perform an action. We did it. What is a function? I'm like, how do I word that? It's a set of instructions, right? Is a function's collection of statements execute sequentially. That's probably important to say. But I got that. Yay. What is the name of the function that all programs must have? Main. Wait. Yes. Main. Yeah. When a program is run, where does execution start? Top to bottom. First statement inside the main function, basically, yeah. What symbol are statements in C++ often ended with? A semicolon. There's a syntax error. It is a grammatical error in coding. Syntax error is a compiler error that occurs at compile time when your program violates the grammar rules of C++ language. What is the C++ standard library? The IO stream? Like, I don't know. I don't really... I want to see the hint. I don't know. I feel like I have to say it. Oh. A library is a library file is a collection of precompiled code that has been packaged up for reuse in other programs. The C++ standard library is a library that ships with C++. Contains additional functionality to use in your programs. Okay. Alright. Next lesson. Can't undo if I compile. That's not good. Well, I'll just reopen it. Actually, I'm not gonna touch it till they're like, okay, let's do this. Alright. A comment is a programmer readable note that is inserted directly into the source code of the program. Comments are ignored by the compiler and are for the programmer's use only. In C++, there are two different styles of comments, both of which serve the same purpose to help the programmers document the code in some way. Single line comments. The \\/ symbol, or is that /? Jeez, I'm so terrible at that. It's /, right? If it's to the right, it's forward. Anyways, it begins a single C++ single line comment. Sorry. The / symbol begins a C++ single line comment, which tells the compiler to ignore everything from the / symbol to the end of the line. For example, what was it? It was character output, right? Okay. Everything from here to the end of this line is ignored. Okay. Typically, the single line comment is used to make a quick comment about a single line of code. Lives in the IOStream library. These comments make the code hard to read, especially when lines are different lengths. Having comments to the right of a line can make both the code and the comment hard to read, particularly if the line is long. If the lines are fairly short, the comments can simply be aligned, usually to a tab stop like so. Okay. This is much easier to read, don't you think so? I guess so. However, if the lines are long, placing comments to the right can make your lines really long. In that case, single line comments are often placed above the line it is commenting. Yeah, this is what I'm used to seeing. It's like right above, then do the code, and then I do like this, but I feel like I'd constantly have to be going back. Like if I made a line that's a bit longer, I'd have to go back and like realign them, when this could just be the like subject line, you know? Author's notes. In this tutorial series, our examples fall into one of the following categories. Full programs, those with the main function. These are ready to be compiled and run. Snippets, small pieces of code such as statements above. We use these to demonstrate specific concepts in a concise manner. We don't intend for you to compile snippets. If you'd like to, you'll need to turn them into a full program. Typically, that program will look something like this. Okay. Copy that down. Just because, shoot. Alright. Okay. The / asterisk and * pair of symbols denotes a C-style multi-line comment. Everything in between the symbols is ignored. I like that. Since everything in between the symbols is ignored, you'll sometimes see programmers beautify their multi-line comments. This is a multi-line comment. The matching asterisk to the left can make this easier to read. I guess, yeah. Multi-line comments cannot be nested. Sequentially, the following will have unexpected results. This is a multi-line comment. This is not inside the comment. It above ends at the first, not the second. Jeez, I see what it's saying. Like, they have it like swapped. The compiler tries to compile this. It will ignore everything from the first slash to the first second slash. Sorry, this is like getting hard to read because it's just symbols. Since this is not inside the comment, is not considered part of the comment, the compiler will try to compile it. That will inevitably result in a compile error. This is one place where using a syntax highlighter can be really useful, as the different coloring for comment should make clear what's considered part of the comment versus not. Yeah. Warning. Don't use multi-line comments inside other multi-line comments. Wrapping single line comments inside a multi-line comment is okay. Okay. Proper use of comments. Typically, comments should be used for three things. First, for a given library, program, or function, comments are best used to describe what the library, program, or function does. These are typically placed at the top of the file or library, or immediately preceding the function. For example, this program calculates the student's final grade based on their test and homework scores. This function uses Newton's method to approximate the root of a given equation. The following lines generate a random item based on rarity, level, and a weight factor. All of these comments give the reader a good idea of what the library, program, or function is trying to accomplish. Without having to look at the actual code, the user, possibly someone else, or if you're trying to reuse code you've previously written, can tell at a glance whether the code is relevant to what he or she is trying to accomplish. This is particularly important when working as part of a team, where not everybody will be familiar with all of the code. Second, within a library, program, or function described above, comments can be used to describe how the code is going to accomplish its goal. To calculate the final grade, we sum all the weighted midterm and homework scores and then divide by the number of scores to assign a percentage, which is used to calculate a letter grade. Okay. Oh, dang. These comments give the user an idea of how the code is going to accomplish its goal without having to understand what each individual line of code does. Third, at the statement level, comments should be used to describe why the code is doing something. A bad statement comment explains what the code is doing. Oh, like why you put it there. I see. If you ever write code that is so complex that needs a comment to explain what a statement is doing, you probably need to rewrite your statement, not comment it. Here are some examples of bad line comments and good statement comments. Set site range to 0. Site 0. Yeah, you're like, clearly I set the site range to 0. Like, why am I commenting that? I can see that I set the site range to 0. Yeah, reason. We can already see that the site is being set to 0. I look at the statement. Site to 0. The player just drank a potion of blindness and cannot see anything. I see. Now we know why the player's site being set to 0. Calculate the cost of items. Right. Cost equals quantity. Like, yeah, clearly you're calculating it. But why is quantity multiplied by 2? Good comment. We need to multiply quantity by 2 here because they're bought in pairs. Yeah. Oh. Programmers often have to make a tough decision between solving a problem one way or solving it another way. Comments are a great way to remind yourself or tell somebody else the reason you made one decision instead of another. I put my earbuds in, so I'm like, ooh, I like this song. We decided to use a linked list instead of an array because arrays do insertion too slowly. We're going to use Newton's method to find the root of a number because there's no deterministic way to solve these equations. Finally, comments should be written in a way that makes sense to someone who has no idea what the code does. It is often the case that a programmer will say, "It's obvious what this does. There's no way I'll forget about this." Guess what? It's not obvious, and you will be amazed how quickly you forget. You or someone else will thank you later for writing down the what, how, and why of your code in human language. Reading individual lines of code is easy. Understanding what goal they are meant to accomplish is not. Okay. Best practice. Comment your code liberally and write your comments as if speaking to someone who has no idea what the code does. Don't assume you'll remember why you made specific choices. Author's note. Throughout the rest of this tutorial series, we'll use comments inside code blocks to draw your attention to specific things or help illustrate how things work while ensuring the program still compile. Astute readers will note that by the above standards, most of these comments are horrible. As you read through the rest of the tutorials, keep in mind that the comments are serving an intentional educational purpose, not trying to demonstrate what good comments look like. Okay. Commenting out code. Converting one or more lines of code into a comment is called commenting out your code. This provides a convenient way to temporarily exclude parts of your code from being included in your compiled program. To comment out a single line of code, simply use the / style comment to turn a line of code into a comment temporarily. Uncommented out and commented out. To comment out a block of code, use / on multiple lines of code, or asterisk style comment to turn the block of code into a comment temporarily. Okay. There are quite a few reasons you might want to do this. You're working on a new piece of code that won't compile yet, and you need to run the program. The compiler won't let you compile the code if there are compiler errors. Commenting at the code that won't compile will allow the program to compile so you can run it. When you're ready, you can uncomment the code and continue working on it. You've written new code that compiles but doesn't work correctly, and you don't have time to fix it until later. Commenting out the broken code will ensure the broken code doesn't execute and cause problems until you can fix it. To find the source of an error. If a program isn't producing the desired results or is crashing, it can sometimes be useful to disable parts of your code to see if you can isolate what's causing it to not work correctly. If you comment out one or more lines of code and your program starts working as expected or stops crashing, odds are whatever you last commented out was part of the problem. You can then investigate why those lines of code are causing the problem. 4. You want to replace one piece of code with another piece of code. Instead of just deleting the original code, you can comment it out, leave it there for reference until you're sure the new code works properly. Once you're sure your new code is working, you can remove the old commented out code. If you can't get your new code to work, you can always delete the new code and uncomment the old code to revert to what you had before. Commenting out code is a common thing to do while developing, so many IDEs provide support for commenting out a highlighted section of code. How you access this functionality varies by IDE. Okay. If you always use single line comments, for your normal comments, then you can always use multi-line comments to comment on your code without conflict. If you use multi-line comments to document your code, then commenting out code using comments can become more challenging. Okay. If you do need to comment out a code block that contains multi-line comments, you can also consider using the if process. Oh my gosh. Okay. Summary. At the library, program, or function level, use comments to describe what. Inside the library, program, or function, use comments to describe how. At the statement level, use comments to describe why. What? Okay, the what is like what the function is doing, what the function is pulling. But a statement, you clearly know what a statement is doing, so you're saying why you're using a statement. Okay. And you can describe how the function is working. Or program. Okay. I understand that. Data and values. We have a video. Can I don't have to watch the video, right? I think that was what I was seeing, was like I would see a video, but then I'd see so much. It didn't seem like the section was just like, here's a video, watch this. Yeah, it looks like whatever is in the video is probably all of this, you know? Just because I don't need any issues with this series, I guess. Drinking some water, hang on. Okay. No, it's not Bill Nye time. We gotta open the textbook, okay? I just realized, what is this here? Was that always like that? I don't think so. I don't know. I'll ignore it for now. I ain't got no time for that. Anyways, okay. Data and values. In lesson 1.1, statements and the structure of a program, you learn that the majority of instructions in a program are statements, and that functions are groups of statements that execute sequentially. The statements inside the function perform actions that hopefully generate whatever result the program was designed to produce. But how do programs actually produce results? They do so by manipulating, reading, changing, and writing data in the computing. In computing, data is any information that can be moved, processed, or stored by a computer. Key insight. Programs are collections of instructions that manipulate data to produce a desired result. A program can acquire data to work within many ways, from a file or database, over a network, from the user providing input on a keyboard, or from the programmer putting data directly into the source code of the program itself. In the Hello World program from the aforementioned lesson, the text Hello World was inserted directly into the source code of the program, providing data for the program to use. The program then manipulates this data by sending it to the monitor to be displayed. Data on a computer is typically stored in a format that is efficient for storage or processing, and is thus not human readable. Thus, when the Hello World program is compiled, the text Hello World is converted into a more efficient format for the program to use, binary, which we'll discuss in a future lesson. A single piece of data is called a value. Value, that was the word I was looking for. Common examples of values include letters, A, numbers 5, and text hello. Random access memory. The main memory in a computer is called random access memory, often called RAM for short. When we run a program, the operating system loads the program into RAM. Any data that is hard-coded into the program itself, text such as hello world, is loaded at this point. Insert Daft Punk. The operating system also reserves some additional RAM for the program to use while it's running. Common uses for this memory are to store values entered by the user, to store data read in from a file or network. Common uses for this memory are to store values entered by the user, to store data read in from a file or network, or to store values calculated while the program is running. Example, sum of two values, so that they can be used again later. You can think of RAM as a series of number boxes that can be used to store data while the program is running. In some older programming languages, like AppleSoft Basic, you could directly access these boxes. You could write a statement to go get the value stored in mailbox number 7532. Objects and variables. In C++, direct memory access is discouraged. Okay. Instead, we access memory indirectly through an object. An object is a region of storage, usually memory, that can store a value and has other associated properties that we'll cover in future lessons. How the compiler and operating system work to assign memory to objects is beyond the scope of this lesson, okay? The key point here is that rather than say, go get the value stored in mailbox number 7532, we can say, go get the value stored by this object. This means we can focus on using objects to store and retrieve values and not have to worry about where in memory those objects are actually being placed. Okay. I see. So they're saying, let the computer decide how to handle what I'm asking it to do. I'm just going to ask it, right? Is that what that means? Like, instead of saying, like, I need this specific thing, it's like, I need mailbox number. I don't know. I don't know how to explain it. I feel like I'm understanding what they're saying. Like, how to use the memory, how to use the RAM, I guess. No. Although objects in C++ can be unnamed, anonymous, more often we name our objects using an identifier. An object with a name is called a variable. That's what I want. A variable. The value is what's in the variable. Key insight. An object is used to store a value in memory. Gotcha. A variable is an object that has a name, identifier. Naming our objects let us refer to them again later in the program. Nomenclature. In general programming, the term object typically refers to an unnamed object in memory, a variable or a function. Excuse me. In C++, the term object has a narrower definition that excludes functions. Okay. Variable indentation, initiation, and what the fuck? Instantiation. Jesus. Okay, let's instantiate. In order to create a variable, we use a special kind of declaration statement called a definition. We'll clarify what the difference between a declaration and definition later. Okay. Here's an example of defining a variable named x. Okay. At time of compile, when the compiler sees this statement, makes a note to itself that we are defining a variable, giving it the name x, and that it is a type of integer. More on types in a moment. From that point forward, with some limitations that we'll talk about in a future lesson, whenever the compiler sees the identifier x, whenever the compiler sees the identifier x, it will know that we're referencing this variable. When the program is run, called runtime, variable will be instantiated. Jesus Christ. Instantiation is a fancy word that means the object will be created and assigned a memory address. Okay. As in, the RAM has accepted it into the system. Into the mainframe. The mainframe. Variables must be instantiated before they can be used to store values. For the sake of example, let's say that the variable x is instantiated at memory location 140. Whenever the program uses variable x, it will access the value in memory location 140. An instantiated object is sometimes called an instance. Okay. Alright. And I'm hoping a lot of stuff like this will be reiterated. I mean, I guess they already have a couple times with other stuff we've learned that they reiterate. I'm hoping stuff like that. It's like, you're throwing so many words at me that, am I gonna remember that? Sometimes it's called an instance, so I'm like, okay, well, is it called that now, or? I don't know. Data types. So far, we've covered that objects are regions of storage that can store a data value. How exactly data is stored is a topic for a future lesson. A data type, more commonly just called a type, determines what kind of value, number, a letter, text, etc., the object will store. In the above example, our variable x was given type integer, which means variable x will store an integer value. An integer is a number that can be written without a fractional component, such as 4, 27, 0, -2, or -12. For short, we can say that x is an integer variable. In C++, the type of variable must be known at compile time, when the program is compiled, and that type cannot be changed without recompiling the program. This means an integer variable can only hold integer values. If you want to store some other kind of value, you will need to use a different type. Integers are just one of the many types that C++ supports out of the box. For illustrative purposes, here's another example of defining a variable using data type double. Double width. Define a variable named width of type double. C++ also allows you to create your own custom types. This is something we'll do a lot of in future lessons, and it's part of what makes C++ powerful. I love that. Okay. For these introductory chapters, we'll stick with integer variables because they are conceptually simple, but we'll explore many of the other types C++ has to offer, including double soon. Defining multiple variables. It's possible to define multiple variables of the same type in a single statement by separating the names with a comma. The following two snippets of code are effectively the same. Oh. True. Okay. When defining multiple variables this way, there are two common mistakes that new programmers tend to make. Neither serious, since the compiler will catch these and ask you to fix them. First mistake is giving each variable a type when defining variables. Yeah, don't do it like again and again and again. Yeah. Second mistake is to try and define variables of different types in the same statement, which is not allowed. Variables of different types must be defined in separate statements. Yeah, get out of here. Yes, definitely. Okay. Best practice. Although the language allows you to do so, avoid defining multiple variables of the same type in a single statement. Instead, define each variable in a separate statement on its own line, and then use a single line comment to document what it's used for. Okay. Summary. C++. We use objects to access memory. A name object is called a variable. In C++, we use objects to access memory. A named object is called a variable. Variables have an identifier, a type, and a value, and some other attributes that aren't relevant here. Sorry, I'm getting annoyed with the parentheses. I'm like, then it'll be relevant later, please. The variable's type is used to determine how the value in memory should be interpreted. In the next lesson, we'll look at how to give values to our variables and how to actually use them. I'm appreciative for the lessons. It's just difficult when reading. Like, reading parentheses is not easy. You know what I mean? It's hard to convey that, like, what I'm saying is a parenthetical. I don't know. But he's also, like, usually saying, but I know I'm saying this, but there's other stuff later. You'll find out later. And it's like, okay. I know. There's stuff later. Question number 1. What's data? Memory stored in the RAM, right? Alright, yeah. I was like, what? It's such a simple question. It's like, I don't know how to, like, really... It's one of those, like, I can't explain the answer because it's a little too simple, but information that can be moved, processed, or stored by a computer. That's a good definition. What is a value? Yeah. What is data? I don't know. What's a value? The value is the like memory or the information of whatever type, the data that you're giving the information, right? Value is a letter, a number, text, or instance of some other useful concept that can be represented as data. Yep, that's the data that you're given. Question 3. What is an object? An object is something that can be stored in memory. I think that's like actually the Ryan used me as an object. Object is a region of storage, usually memory that can be stored, that can store a value. Yes. Okay. What is a variable? A variable is variable is the object. Like, that's why I'm getting like a little, seems like object, type, and variable are all very similar, but kind of like stacked. There's like different levels. Variable is the object that has a name. Okay. Yeah, so it is like the same thing, just kind of different levels. This object is an unnamed variable. Gotcha. An identifier is the name of a variable. It's the name that a variable is accessed by, yeah. What is a data type used for? What? Like, it's used to determine the type of variable? Like if it's an integer or a string or... Data type determines what kind of value the object will store, yes. And then what is an integer? It's a number. Yeah. Yeah. Okay. I think... how long have we been streaming? An hour? I know there's a lot in lesson 1. I don't think we can finish it tonight. Oh, it was less than 13, 12. I mean, we're about to do 4. I feel like we could do half, because... I don't know. I guess I could keep going for a bit. Maybe we'll do 4 and 5. We'll do half. And we'll do this and the quiz another day. Variable assignment and initialization. In the previous lesson, we covered how to define a variable that we can use to store values. In this lesson, we'll explore how to actually put values into variables and use those values. As a reminder, here's a short snippet that first allocates a single integer named x, variable named x, then allocates 2 more integer variables named y and z. Okay. Variable assignment. After a variable's been defined, you can give it a value in a separate statement using the equals operator. I see. This process is called assignment, and the equals operator is called the assignment operator. By default, the assignment copies the value on the right side, The assignment copies the value on the right-hand side of the equals operator to the variable on the left-hand side of the operator. This is called copy assignment. Here's an example of where we use assignment twice. Equals with equals 7. Assigns variable to 5. Change values stored in variable width to 7. Okay. This prints out 57. When we assign the value 7 to variable width, the value 5 that was there previously is overwritten. Normal variables can only hold one value at a time. Gotcha. Warning, one of the most common mistakes that new programmers make is to confuse the assignment operator with the equality operator. Assignment is used to assign a value to a variable. Equality is used to test whether 2 operands are equal in value. Why would this print out 57? That does not seem right. I guess because I'm like, if it's overwritten, width equals 5. Width. Alright, so like, now, character output, what the width is, 5. Okay, width equals 7. Now, output 7. Okay, I guess so. I guess because this got put, if this was here first, it would only output 7, right? Okay. Initialization. One of the downsides of assignment is that it requires at least 2 statements. one to define the variable and another to assign the value. These two steps can be combined. When an object is defined, you can optionally give it an initial value. Process of specifying an initial value for an object is called initialization, and the syntax used to initialize an object is called an initializer. In the above initialization, a variable with 5 is the initializer and 5 is the initial value. What? Let me start. Let me skim through this real quick. That's how I get sleepy, and it's like I'm losing the quality of what I'm absorbing. But I am paying attention to, like, if I'm not absorbing it, I need to slow down. These two steps can be combined. When an object is defined, you can optionally give it an initial value. Process of specifying an initial value for an object is called initialization, and the syntax used to initialize an object is called initializer. Okay. Different forms of initialization. Initialization in C++ is surprisingly complex, so we'll present a simplified view here. There's 6 basic ways to initialize variables in C++. Okay, you just say A, you can say B equals 5, you put in parentheses. See, like, this is reminding me a bit of, like, HTML. You know, like, you can just put it equals, you can, I don't know, there's like different ways you can kind of say the what's the word? Assignment. List initialization methods. C++ 11 preferred. D in squiggles, D equals in squiggles, and then F squiggles. Initializer is empty braces. Why? You may see above forms written with different spacing. Whether you use extra spaces for readability or not is a matter of personal preference. Okay. When no initializer is provided, such as for variable A above, this is called default initialization. In most cases, default initialization performs no initialization and leaves a variable with an indeterminate value. We'll discuss this case further in lesson 1.6. Okay. Copy initialization. When an initial value is provided after an equal sign, this is called copy initialization. This form of initialization was inherited from C. Okay. Much like copy assignment, this copies the value on the right-hand side of the equals and into the variable being created on the left-hand side. The above snippet, variable width, will be initialized with the value 5. Copy initialization had fallen out of favor in modern C++ due to being less efficient than other forms of initialization for some complex types. However, C++ 17 remedied the bulk of these issues, and copy initialization is now finding new advocates. You'll also find it used in older code, especially code ported from C, or by the developers who simply think it looks more natural and is easier to read. I mean, it really does. What? There's something wrong with just saying, like, this equals this? Like, I think it'd be a bit more clear-cut code. Like, there's less characters to read, there's less, like, I don't know. It definitely is just, like, easier to look at, too. Copy initialization is also used whenever values are implicitly copied or converted, such as when passing arguments to a function by value, returning from a function by value, or catching exceptions by value. Okay. Direct initialization. When an initial value is provided inside parentheses, this is called direct initialization. Direct initialization of value 5 into variable width. Direct initialization was initially introduced to allow for more efficient initialization of complex objects, those with class types, which we'll cover in a future chapter. Just like copy initialization, direct initialization had fallen out of favor in modern C++, largely due to being superseded by list initialization. However, we now know that list initialization has a few quirks of its own, and so direct initialization is once again finding use in certain cases. Okay. Direct initialization is also used when values are explicitly cast to another type. One of the reasons direct initialization had fallen out of favor is because it makes it hard to differentiate. There's something wrong with that lesson, because that gap is gone now. I just realized. I did not mean to interrupt it in the middle of a sentence. Direct initialization is also used when values are explicitly cast to another type. One of the reasons direct initialization had fallen out of favor is because it makes it hard to differentiate variables from functions. Oh. Yeah. Forward declaration of function x, definition of variable x with initializer 0. Like, yeah. The modern way to initialize objects in C++ is to use a form of initialization that makes use of curly braces. This is called list initialization, or uniform initialization, or brace initialization. List initialization comes in 3 forms. Direct list initialization of an initial value 5 into variable length. I'm getting a headache from the amount of times I have to say initialization. As an aside, prior to the introduction of list initialization, some types of initialization required using copy initialization. I can't do this. And other types of initialization required using direct initialization. List initialization was introduced to provide a more consistent initialization syntax. I'm like not picking up any of this because I can only see how many times it says it. Additionally, list initialization provides a way to initialize objects with a list of values, which is why it's called list initialization. We'll show an example of this in lesson 16.2. Alright. Jeez. List initialization has an added benefit: narrowing conversions in list initialization are ill-informed. Okay. This means that if you try to brace initialize a variable using a value that the variable cannot safely hold, the compiler is required to produce a diagnostic, usually an error. For example, a number with a fractional value can't fit into an int. Okay. In the above snippet, we're trying to assign a number, 4.5, that has a fractional part to an integer variable, which can only hold numbers without fractional parts. Copy and direct initialization would simply drop the fractional part, resulting in the initialization value 4 into variable width. Your compiler may optionally warn you about this, since losing data is rarely desired. However, with list initialization, your compiler is required to generate a diagnostic in such cases. Conversions that can be done without potential data loss are allowed. To summarize, list initialization is generally preferred over the other initialization forms because it works in most cases and is therefore most consistent. It disallows narrowing conversions, and it supports initialization with lists of values, something we'll cover in future lessons. While you are learning, we recommend sticking with list initialization or value. Okay. I will take your word for it. Best practice: prefer direct list initialization or value initialization for initializing your variables. Woo! Bjarne Strustrup, creator of C++, and Herb Sutter, C++ expert, also recommend using list initialization to initialize your variables. In modern C++, there's some cases where list initialization does not work as expected. We cover one such case in 16.2. It looks like chapter 16 is going to be crazy. Because of such quirks, some experienced developers now advocate for using a mix of copy, direct, and list initialization, depending on the circumstance. Once you are familiar enough with the language to understand the nuances of each initialization type and the reasoning behind such recommendations, you can evaluate on your own whether you find these arguments persuasive. Okay. We may finish this one and then stop. Like, yeah, we're gonna do this one and stop. The initialization stuff is it's taken the wind out of my sails. Value initialization and zero initialization. It's not that he's saying it so much, because he does have to repeat himself a lot with just teaching, but it's the fact that the word is so long and I can't say it great. When a variable is initialized using empty braces, value initialization takes place. In most cases, value initialization will initialize the variable to 0 or empty if that's more appropriate for a given type. In such cases where zeroing occurs, this is called zero initialization. Width is blank, so it's 0. Got it. When should I initialize with 0 versus a blank? Use an explicit initialization value if you're actually using that value. Right, so like if you really actually want it to be 0, set it to 0. Use value initialization if the value is temporary and will be replaced. Okay. Like if data is going to be inserted in there later, then leave it blank. Okay. Initialize your variables. Initialize your variables upon creation. You may eventually find cases where you want to ignore this advice for a specific reason, a performance critical section of code that uses a lot of variables, and that's okay, as long as the choice is made deliberately. For more discussion on this topic, Bjarne Strustrup and Herb Sutter make this recommendation themselves here. We explore what happens if you try to use a variable that doesn't have a well-defined value in less than 1.6. Best practice, initialize your variables upon creation. Initializing multiple variables. In the last section, we noticed that it's possible to define multiple variables of the same type in a single statement by separating the names with a comma. We also noted that the best practice is to avoid this syntax altogether. However, since you may encounter other code that uses this style, it's still useful to talk a little bit more about it, if for no other reason than to reinforce some of the reasons you should be avoiding it. Like, you're probably gonna see it, but we're gonna tell you why you shouldn't do it. And you can look at it in other people's code and be like, okay. You can initialize multiple variables defined on the same line. A equals 5, B equals 6, C is 7, D is 8, E is 9, F is 10, G is 9, H is 10, I is nothing, J is nothing. Okay. Copy brace and direct brace. I see this is probably what people were talking about when they were saying that C++ has interesting data allocation. I think that's what they're talking about here with this. We're going a lot into like if we should use curly brackets or parentheses or nothing, or I don't know. Unfortunately, there's a common pitfall here that can occur when the programmer mistakenly tries to initialize both variables by using one initialization statement. Gotcha. Yeah, A doesn't have anything actually defining it. In the top statement variable, A will be left uninitialized, and the compiler may or may not complain. Okay. If it doesn't, this is a great way to have your program intermittently crash or produce sporadic results. I'll talk more about what happens if you use uninitialized variables shortly. The best way to remember that this is wrong is to consider the case of direct initialization or brace initialization. Okay. Because the parentheses or braces are typically placed right next to the variable name, this makes it seem a little more clear that the value 5 is only being used to initialize variable B and not D, not A or C. Okay. Unused initialization variables warnings. Modern compilers will typically generate warnings if a variable is initialized but not used, since this is rarely desirable. And if treat warnings as errors is enabled, these warnings will be promoted to errors and will cause a compilation to fail. Consider the following innocent-looking program. Dun, dun, dun. Oh, when compiling this with the G++ compiler, the following errors generated. Unused variable. I always wondered like why that was upset, but it's because it's like loading it in there and it's like, why are you telling me to load this? I'm not using it. And the program fails to compile. And the program fails to compile. There are a few easy ways to fix this. If the variable really is unused, then the easiest option is to remove the definition of X, or to comment it out. After all, if it's not used, then removing it won't affect anything. Another option is to simply use the variable somewhere. Okay. I see. It's now used somewhere because I'm asking it character output whatever X is, which is 5, so it would say that it's 5. This requires some effort to write code that uses it, and it has the downside of potentially changing your program's behavior. Okay. The maybe unused attribute. Okay. In some cases, neither of the above options are desirable. Consider the case where we have a set of math physics values that we use in many different programs. Okay. If we use these values a lot, you'll probably have these saved somewhere and copy, paste, import them all together. However, in any program where we don't use all of these values, the compiler will likely complain about each variable that is actually used. While we could go through and remove, comment out the unused ones for each program, this takes time and energy. And later, if we need one that we've previously removed, we'll have to go back and re-add it. To address such cases, C++17 introduced the maybe unused attribute, which allows us to tell the compiler that we're okay with a variable being unused. The compiler will not generate unused variable warnings for such variables. The following program should generate no warning errors. Interesting. You can literally say, like, I'm putting this here, but I don't know if I'm going to use it, so just leave it alone. Leave me alone. Okay. I like that. Additionally, the compiler will likely optimize these variables out of the program so they have no performance impact. The maybe unused attribute should only be applied selectively to variables that have a specific and legitimate reason for being unused. In future lessons, we'll often define variables we don't use again in order to demonstrate certain concepts. Making use of maybe unused allows us to do so without compilation warnings errors. Quiz time! What's the difference between initialization and assignment? So assignment is for sure like the equal sign. Like I'm assigning this data value to this variable. Initialization I believe is just calling the variable, like allocating the space for the variable, right? Like the program is initializing that. Okay, this. I think I'm making it too complicated. Initialization gives a variable an initial value at the point when it's being created. Assignment gives a variable a value at some point after the variable is created. Like, initialization in my head is like the creation of the variable. And the assignment is like what the actual value is. But no, initialization gives a variable an initial value at the point it's created. Okay. What form of initialization should you prefer when you want to initialize a variable with specific value? Well, they want me to do it was copy, or sorry, direct brace initialization. Right? Did I say that? Yeah, I did. Direct list initialization. Oh. I don't know anymore. What are the default initialization and value initialization? It's like my brain got so lost in this word, I did not retain any of this. What are the default initialization and value initialization? What is the behavior of each? Which should you prefer? Default initialization is 0, but are also none. So it's like temporary, can be replaced. Value initialization is setting a set value. There's a behavior of each. That I just said it. Which should you prefer? I think it depends on what's needed, right? Like if you need it to be a set number or something like that, right? Oh no, I should prefer value to default. Okay, I see what they're saying. Like, if you can define it, just do it. Like, don't let it guess. Right? Are they meaning... I think I get it a little bit now. So this is the initialization, and then this gets called. And so you can, when you call it later, wait, this isn't a good one. I don't know. Like, define it right there. Like, you can define it later, I believe. That you should... I don't know. We'll figure it out later, I'm sure. Ay. I think... let's do a little... this again... and then we'll rate out. That was not the best, but we're just starting, and I'm sure they're gonna repeat stuff. They're gonna repeat stuff, and it's gonna be great. Great. We're gonna start getting it, like, as we're going and doing and building. it'll start to make sense. The M got me last time. It's like I need to make sure I go slow. A lot of this stuff I know, it's difficult. It's not difficult. Honestly, this is really good. Like, it asking those questions and I'm like, well, it's a bit too simple. I don't really know how to explain it. Yeah, I really should be able to explain it. If I can't explain it in simple words, then I don't understand it well enough. I'm wanting to maybe do a couple sections, like, or maybe do like one section, I don't know, that would start getting a little chaotic with my VODs and everything, but I kind of want to just like play Sims tomorrow, but then after stream, or like after playing the Sims, do a one lesson or like one section, you know? Yeah, I don't know if I'm gonna do Sims. I may do, I don't know. I kind of was thinking Theme Hospital, but I don't know if I want to get my, I don't know if I want to hurt myself again. You know? It's the last level. I don't know if I have it in me. But it is for sure, I need to do it before I die. I need to beat Theme Hospital. I just wrote theme. Oh my god. Fuck. It's also a bit of a bitch to get the gameplay looking okay on stream, because I have to like adjust it, or I have to like look at it, close the game, or like adjust it, close, I don't know, I remember. It was a lot of like having to reopen the game a bunch to see, because like if I clicked away it would mess up the full screen. And so I'd have to like look at it, see if it was right, go adjust it in OBS, and then close the game, open it again, and see if the adjustment was correct. Like it was a bit frustrating. Okay, we did it. That was a good amount. I mean, that was introduction to the IO stream. Like, this will be, that's beefy information. Like, I'm not starting that for sure. We did it. Okay, let me find who we're raiding out to. Ooh, oh my goodness. Bad Barbie, thank you. I am actually just raiding out. I think we are going to raid out to dropped into one of his TikTok streams. Like, So let's go say hi. Is he ending stream? How long has he been streaming for? No, he just started. Okay. So he's gonna be playing Crow Country, which I've not seen a full playthrough of it, but it is very high quality, I'm gonna say. Like, there's for sure an attention to detail. I really enjoy it. There's a lot to love about it. So let me start that raid. This is the raid message, if that works. Yay! Oh, it only did one of them. I'm gonna try one more time or something. That's just wrong. Oh, there it goes. That's interesting. It only did one. Okay. I hope you guys have a good night. I might be live tomorrow. Oh, good. This is what I'm like mostly focused on right now is getting this stuff done. So I'm trying to do like a whole series of me learning it from the start. So should be back next Tuesday. I also might do some more of this at the end of other streams. I don't know. But have a good night. I'm going to go to bed and I'll see y'all around. Bye.